Our next fundamental skill from Math 084 is solving a system of linear equations using the method of elimination. So here's a system of linear equations. 2x plus 3y equals 6, and 5x minus 6y equals 10. And the idea behind using elimination is we want to arrange it so that for one of these two variables, the coefficients, the constant number multiples in front, match but are opposites. If you look at the y's here, one has 3 and the other is minus 6. These would be the same if in the first equation we multiplied everything by 2. So that's what we're going to do. Remember, one of the things you can do with an equation is just multiplying both sides by any constant you want. So let's take this first equation and multiply everything by 2. That gives us 4x plus 6y equals 12. And now looking at these two equations, so the unmodified equation from the system here, and then our modified equation there, these two equations have the same coefficient in front of the y, except they're opposites. So when we go to add these equations together, all of the y's here are going to cancel. So we get negative 6y plus 6y is no y's. 5x plus 4x is 9x. And then on the right-hand side of the equation, 10 plus 12 is 22. All right, and now this equation doesn't have any y's in it. It only has x's. And that means we can solve this remaining equation for x. So we can just divide both sides by 9. And we get x is 22 over 9. And that's going to be, what, something like 2 and 4/9. I'll probably stick with 22 over 9 for now, though. We aren't quite done yet, though. We know x, but remember, to solve a system of equations, we need to know x and y. So we need to go back and find y. To do that, we can take any of these equations up here that we started with, any of these three, whichever one we think is most convenient to work with. Just for no real reason, I'm going to use this first one. Now we know what x is, so let's plug in our value of x. We get 2 times x, and x we now know is 22 over 9, plus 3 times y equals 6. Now this equation doesn't have any x's in it. It only has a y. So we can solve this equation for y. We'll start by doing this multiplication over here. We get 44 over 9 plus 3y equals 6. And then we'll subtract 44 over 9 from both sides. We get 3y equals, let's see, 6 is 54 over 9. Minus 44 over 9 is going to be 10 over 9. And then divide both sides by 3. And we get y is 10 over 27. All right, so here's our solution. X comma y is going to be equal to 22 over 9, comma, 10 over 27. You can tell I didn't pick these numbers very specially, because the solution turns out to be a bit messy. That's fine. Usually if you get nice, pretty integer answers, that means somebody made the problem specially to make it turn out nicely for you. Okay, so that's sort of typically what happens when you use elimination. You eliminate one variable, solve for the variable that's left, then use one of the original equations to get the remaining variable. Okay? So let's look at another example, because there are a couple other things that can happen when you're solving systems of linear equations. So here's another system of two linear equations. So let's solve for x and y. Remember, the goal here is to somehow arrange for the coefficients on one of the variables to match except to be opposites. So looking at maybe the x's this time, it looks like if we multiplied the second equation by 2, then we would have a negative 4x here in the second equation. So let's do that. We're going to multiply both equations, or both sides of this equation by 2. So the first equation we're going to leave alone. So it's still 4x minus 2y equals 3. And then the second equation we're going to multiply by 2. So minus 4x plus 2y equals 8. So here's our new system right here. And we're going to take these two equations and add both sides. So adding left-hand sides, 4x minus 4x is no x's. And minus 2y plus 2y, that's no y's. So we get a 0 here. And then on the right-hand side, 3 plus 8 is 11. Okay, so remember, we were trying to eliminate x, and we were expecting to get an equation that would tell us about y. Well, so this equation is trying to tell us something about y. What sort of values for y does this equation describe? Well, there's no way to choose y so that 0 is equal to 11. And that means there are no possible y values that work for this system of equations. And that means there are no solutions. So this system of equations has no solutions. Okay, so it's possible to get exactly one solution, like in our first example, and it's possible to get no solutions, like in the second example. There is a third possibility, so let's look at a third example. Okay, so solving this system using elimination. Looking at the coefficients in front of x and y, it doesn't really look like there's a quick and easy way to get any of them to match. But there always is a way to get them to match. It just isn't quick and easy. So let's take this first equation and multiply it by negative 5. And we'll take the second equation and multiply it by 3. Now I chose these multiples, negative 5 and 3, so that, right, if you look at these here, the 5 in the second equation, that made me choose negative 5 for the first one, and the 3 in the first equation, that made me choose a 3 in the second equation. So now when we multiply these out, the first one we get negative 15x plus 5 times 6 is 30y equals, let's see, negative 5 times 6 is negative 30. And then taking the second equation and multiplying it by 3, we get positive 15x minus 3 times 10 is 30y equals 3 times 10 is 30. All right, so here's our new system of equations. And now we can add both sides. On the left, negative 15x plus 15x is no x's, 0 times x, which is 0. And 30y minus 30y, there's 0y, so 0 on the left-hand side. On the right-hand side, negative 30 plus 30, that's also 0. So we were trying to eliminate x, and that means we expected this equation to tell us about y. But there aren't any y's in this equation, so what values for y make this equation true? Well, 0 is always equal to 0. So any y value will work for this equation. That means there is a solution to this system no matter what y value we want. But that doesn't mean that just any x value goes with any y value. To get the x value that corresponds to a y value, you go back and use one of the original equations. Which original equation? Well, any of them. We could use the first one, 3x minus 6y equals 6. So this equation describes all of the solutions to this equation, of course, to the system of equations. Of course, this equation has infinitely many solutions, since it's just a line. And that's the final possibility for what can happen with a system of equations. You might have infinitely many solutions. Okay? So it's when everything cancels in your equations and you're left with 0 equals 0, or 1 equals 1, or 3 equals 3, something like that, that's when you have infinitely many solutions. So the three possibilities for when you solve a system of two equations with two unknowns is you could have exactly one solution, no solutions at all, or infinitely many solutions.